Good evening. How is everybody doing? Good. My name is Blake Nancarrow, and I wanted to talk to you about my BDT plus ABB. That's the barn door tracker with Alt-Az, or adjustable base. I was always interested in these, knew about these from a long time ago, but never really felt compelled to do something about it. But I'll talk about who convinced me to do it, whose fault it was, and why I decided to proceed with this and so on. In case you're not familiar with it, a barn door tracker, this is not mine, obviously this image here, but that's how simply you could make one. Maybe you've got all those parts at home, so you wouldn't have to spend anything, just rummage through the bins and find a hinge and make a little dial or a wheel that's calibrated. You can see that this is manually controlled. This is what people did though in the early days with simple home-built barn door trackers. They manually adjusted that dial at a prescribed rate, and that opens up the hinge at the right rate, and ultimately what you're trying to do is compensate for the rotation of the Earth. You may know that if you put a camera on a fixed tripod and aim up at the sky after 15 seconds, 30 seconds or so, you're going to see that your stars are becoming stretched, little curved arcs. It depends on your focal length and other factors, your lens and so on. But in general, when you start doing long exposures, 30 seconds, 60 seconds, a couple of minutes, you're not going to have round stars anymore. So a barn door tracker or some sort of tracking device is needed if you want to do wide field photography of some kind. This is maybe what a lot of people think of as the classic barn door tracker. Two pieces of wood, you can see there's a little hinge between them, there's a screw here or a bolt that is turned once again at a prescribed rate, and it makes those two boards move apart. You see the little string here as a catch so it doesn't flop open, and I think this is very clever here. I'm pretty sure that's just the body of a pen, an old pen that's hollow, plastic tube, and somebody's glued it to the hinge to do the polar alignment. So again, you could build one of these out of spare parts, really simple, easy to do. I wasn't really interested in a design like this though, because you have to manually touch this unit, and part of what you're trying to do with these two barn door plates is track the stars smoothly, move your camera smoothly. So I didn't want to build something that would require any manual intervention. So I was interested in a motorized solution if I was going to do this. But I was really sitting on the fence. I didn't know whether I should make one of these or not. These sometimes are called Hague mounts or Scotch mounts. And you're trying to, once again, you're trying to compensate for the diurnal rotation of the Earth. It's not the sky moving, it's the Earth turning underneath the sky, of course. Another reason that I wasn't really super keen initially at doing something like this is because you can do piggyback photography. I'd already done that a little bit. You can put your camera on top of your telescope, which is on an equatorial mount, and then you can do wide field photography that way. I'd done that with a couple of different telescopes. And this whole field is getting very interesting. It's a really hot sort of segment within our hobby, people doing photography like this. So there's lots of equipment that I had opportunities to try out. I was able to borrow some of these types of devices. This is one of the first ones that I had seen. One of our members, Steve McKinney, brought his AstroTrack up to the Carr Astronomical Observatory, the CIO. So I saw this in action. It's a swing arm design. They have a limited range of motion. It depends how long that screw or rod is in there. But that's one design. And you can see there's a camera with a fairly long lens on it and a counterweight. So this is one type of design that you can get. Some of you may have seen these. Some people may have this. The Vixen Polaria is quite possibly the smallest tracker unit. you can see that's about the size of a point-and-shoot camera, or a small, maybe a micro four thirds camera. And that wheel turns, once again, at a 24-hour rate, at the sidereal rate, so very compact. And I don't know if you can see it well in this photo, but there's a little sight hole like the old rangefinder cameras to do your polar alignment. So that's another type of design. This is perhaps the most popular one. Who's got one of these? There's a couple of people maybe that have the Star Adventurer. The Toronto Centre owns one of these. It's up at the CAO. When you're visiting the CAO, you can book time on that. You can use that. You can try it out. I've used it a couple of times to get familiar with it. It's really a mini baby equatorial mount. And you can see it's got a polar scope in it. So when I used it, I found it pretty straightforward. I'm familiar with an equatorial mount, how to polar alignment. So pretty easy to use. You can get the counterweight kit, so you can put a small telescope on it, or a camera with a big lens. So again, that's probably one of the most popular devices there. I had an opportunity to try this unit. Risa Horowitz, one of our members, has the Ioptron Sky Tracker. It's a little bit bulkier than the Vixen Polari, but you can see it has an integrated base, so it's easy to hook up to a tripod, easy to get the latitude angle to begin your polar alignment. It's got a sort of a classic polar scope in it there. So the manual, poorly written as usual, but I waded through that and was able to get it to work without too much effort and got satisfactory results with that. So again, this is a really hot area. This is one of the newest units that I've seen, the Fornax unit. I don't know anybody that has one of these. All of these commercial Star Tracker units are in the $300, $400, $500 range, which is about the price you would pay for a lightweight equatorial mount. So again, I was sort of really sitting on the fence. I didn't want to spend a lot of money necessarily on one of these. I was just sort of looking at what was going on in the field. And I have this. I have the classic Vixen Super Polaris mount. And that's a lightweight equatorial mount. It's very highly regarded. It's nice and smooth. I have hacked mine, so I've got motors on it. I can track. I can do go-to on it. So you can do, I could not put my telescope on that, just hook my camera up to it, and I've got the same sort of solution. So I thought, well, I'll just use my Vixen Super Polaris to do wide field imaging. It has decent payload capacity, except now if I'm using it, I don't have my telescope in operation. So it was on talking with Ian Wheelband, it's all his fault, that he and I started talking about this in some detail, and he told me he had built one. So I was intrigued by that. He had based his on Gary Saranack's design. So if you look up Barn Door Tracker, Gary Saranack, you'll find his design, all his plans and stuff. So wood plates, hinges back here, motor, so it's hands-free, all the gearing and stuff. There's a curved rod, a little bit hard to see. You can just make out the curved rod underneath there. Gary added a little finder scope to it to help get to polar alignment. You may need a ball head. I didn't have one, so I had to get one of those to make all this work. But it's a nice design. Ian showed me that website, so I sort of checked it out. And Ian brought his barn door tracker that he had built to the Algonquin Radio Observatory. A bunch of us went up there, so I had an opportunity to try it out. The skies weren't great, but I was able to do a bit of long exposure tracking with it. Then he told me he had the parts. That with another astronomy group, a bunch of the members had decided to build barn door trackers. So somebody organized all the parts, got all the gears, made the curved rods, got a bunch of the electronics. They put these kits together that members could buy. And Ian said, I've got all the parts to make a kit. So I bought one of those kits from him when I decided to finally pull the trigger on this. Ian sent over his electronic diagram, slightly different from Gary's. Ian had added an external power supply so he wanted to protect the voltage regulator. He put some diodes on it. This was sort of illuminating for me because I've been teaching myself component electronics, so I looked at the circuit and I understood it. I knew what was going on, knew that it would be easy to build that. So again, the bug bit, I decided to go ahead and do this because I have the tools. I might have some of the talent. I like the idea of a compact solution that runs on just a battery, so a regular battery that's hands-free, that could be tracking the sky with my camera while I'm doing stuff with my telescope. I like the idea of multitasking. I like the scope of this project. It's small. I'm not an ATMer. Clay, I admire you. I'm not. Maybe one day I'll build a telescope, but there's no way I'm going to grind a mirror. There's no way I'm going to do that. I do not have. I'm just going to buy the focuser. I'll buy the mirror, and maybe I'll make the wood bits of it. But I like this because it was small. You know, a small project, something I could do on rainy days, and I assumed it would be fun and rewarding and stuff like that. So lots of reasons. Sort of a lot of things came together for me to decide to go ahead to do this. So September 2014, I start working on this project. I get the kit from Ian. I don't know if you can see all the bits and bobs in there, but that's a lot of the things that would be needed to make it work. There's the hinges. There's some electronics. You can see a capacitor in there, the voltage regulator, the rheostat or the pot for changing the speed of it. The gear, the rod was already curved. Yay, I didn't have to do that. There's the motor. So I had the kit. There were a few pieces missing, so I had to add to that. So I prototyped it. I put all the bits together and tested it and found right away a problem. I didn't notice it at first. The motor here has a battery pack attached, and that's a single cell. That's a C cell or a D cell battery pack. Single battery. And Gary's design called for a 3-volt motor. This was a 1.5 volt motor. So right away I saw when I did my prototyping, the motor's spinning way too fast. It's twice as fast as what it should be. So I start sort of thinking about that. How do I solve that? How do I adapt it? I also wanted a power indicator. I wanted to be able to see when I had the unit on. I don't know if you could see it in there, but there's a little red LED indicator. So because you always forget to turn these off at night. So I designed my own circuit. Well, I modified Gary's circuit here. So it runs on a 9-volt battery. There's my power indicator LED. I kept Ian's diodes in there to protect the voltage regulator if I want to hook up an external power supply. There, R2 is the variable resistor to increase or decrease the speed. 1.5 volt motor, I kept it. I could have changed the voltage regulator or the motor. I didn't want to do that. I just wanted to keep all the parts that I had. And I knew I had learned enough about electronics while it's crude that I could do voltage dividing. So the resistors here at the end take care of that. I got the voltage at the proper level. This was a really satisfying part of the project because for me, I hit a threshold. I was able to start to build or design my own circuit. So I was really happy with that. When I prototyped it, it all worked. So I assembled all the parts, I made the circuit board, I made this box, the control unit, and so on. That was sort of silly to do a clear plastic, but I wanted to show it off to people. But this was a frustrating part of the project because I made one mistake when I was soldering, and some of the components actually failed. So it took me a long time to get this working, many nights scratching my head and trying to debug the circuit, but I got it all working. So that was done in December 2014. So I moved to the next step, and that was to get the wood, or at least try to find the wood. I don't know how many hardware stores I went to, and I was not going to buy a 4x8 sheet of plywood to make my little barn door tracker, but I wanted some nice wood. Ian, once again, came to the rescue. He had an extra piece of Baltic birch, so I bought that from him for a few lug tread beers, and if you need stuff from Ian, that's the way to do it, is just hand him a lug tread, and there you go. So with the help of Tony DeSantos' jigsaw, I cut the plates. You can see I varied a bit from Gary Saranick's design. I didn't do the curvy bit here, so I just cheated. Straight straight cut. And then then later in 2015, I assembled all the pieces. So this is looking from the bottom, and there's the motor, power or data connector, if you will. The upper plate, you can see a bit of the hinge there, and here's the side view. Over the Christmas holidays, I had retrieved an unused or a spare finder from my old Celestron 8-inch SCT telescope. So you can see I put this on here to help me get to Polaris. And behind it, you can see the ball head. So again, I had to purchase a ball head. So not strictly part of the barn door, but that was an expensive element to acquire. But here it was all ready to go. So here's first light. On the 24th of March 2015, I took it to the city observing session at Bayview Village, and can you see the numbers down at the bottom? I have a 55 millimeter lens. 5.6. Yeah, so 120 seconds, 2-minute exposure, and if you look closely at those stars, that's the bottom of Orion right there, pretty round. So I was happy with that. The first use of it, it looked like it was working pretty good. I was happy with the results, but was learning stuff at the same time. I could not aim up high. The body of the camera was hitting the top plate, so I had an interference or a height elevation problem that I needed resolved. But I calibrated it, counted the number of teeth on the gears, how long it took for that to go around, did all that. Did another shot, and here I'm at 180 seconds plus, and still pretty round stars, except I bumped the stupid lens, so it knocked it out of focus, but still round stars, so happy with it. It was working. But a challenge that I was experiencing, even at the early stages, was how do I get to Polaris, and how do I know I'm on the North Celestial Pole? So that was in the back of my mind. Took it, put it into real use. I went with Nicole Mortellero up to the Forks on the Credit. Darker skies, obviously, April 2015. Did not a terribly long exposure, but got a nice result with Orion there. And then I aimed in a slightly different part of the sky, and there's Jupiter beside, do you see it? The Messier 45. So again, pretty round stars there, 45-second exposure, happy with that result. So first use of it, I was getting encouraged, things were working right. Took it up to the CAO on June 2015, aimed towards Scorpius. I believe that's Saturn at the time, just above Scorpius right there. And not great focus, but slight trailing as well. But I was trying out a fisheye lens, the Rokinon 8mm fisheye on my Canon 40D, which is the APS-C chip. But once again, a 2-minute exposure and pretty good sort of results there. But I was getting increasingly worried about the issue with respect to polar alignment. And I used that little finder scope right here, and I was wondering, how do I know that that is aligned with that hinge? You know, like the little pen tube. You know, how is it perfectly aligned? I wanted it to be coaxial. And that's a true finder scope. It's not a polar scope. Polar scopes have those nice reticles in them. It tells you where to put Polaris so that you're on the North Celestial Pole. I wasn't using something like that. So I had to figure that out. I just used my software to help me figure out where the North Celestial Pole should be in relation to Polaris. So that's easy to simulate, and I have a chart now that I print out periodically, and I take that into the field. But I was still trying to figure out the axial alignment, and I got it in my head for some reason that if I move the finder scope to the bottom plate where you see it now, this would avoid collisions up top with the camera. I'd have more real estate and so on, but I was still sort of perplexed by that. I continued to look at other people's designs. Here you can see the finder scopes on the bottom, curved rod again, and so on. So I like that design. The top plate free and clear. I was also worried a bit about weight. You know, how much torque can that motor generate? I don't know exactly. So I just thought I'll reduce the payload on the top as much as possible. So move things down to the bottom, and that yielded version 2. I made a bigger plate. to handle the finder scope on the bottom. I did the finishing of the wood. I put labels on the control unit and so on. So again, slowly progressing here through the summer of 2015. Then I considered how to accurately and smoothly and progressively reach the North Celestial Pole. Your equatorial mount has azimuth screws and elevation screws to let you dial in precise polar alignment. So I considered a slow motion control. Orion has these little tiny controls. They're really built for binoculars. They're fairly lightweight, but I knew something like this would work for fine adjustment, so I borrowed one of these to try that out. I considered a geared head. There's the Manfrotto one. Anybody know how much those are? They're like $300 or $400 just by themselves. A pro grade. I didn't want to do that, and somehow it felt out of place as well, something like that under this. I wanted something that was integrated and made with the same stuff, made with the same parts, that would do the altitude and azimuth. So I continued researching things. I stumbled across this design by this person, ZZJ. I don't know who that is, but if you look up, again, Barn Door Tracker ZZJ, you'll find this design. That's not suitable for work, so read that, at home. But there were lots of things that caught my eye. The finder's on the bottom again. There's a little wire rope here to prevent it from snapping opening, and a bearing. I thought, ooh, that's clever. I thought this was a neat idea. Put the little polar aid right on it. That's just a round piece of paper. You could use a CD if you wanted to. And then I saw this. See it? More wood plates, hinge, screws. I went, aha, this has an altitude azimuth adjustment on the bottom. That's the back. Here's the front of it. See the screw, more additional wood plates. This is quite a complex design that this person has built, but there's the altitude screw. I knew I didn't need that much. I needed a degree or so to change the altitude. There's the azimuth screw, but I just liked how it was made out of simple parts again. So that gave me some ideas. So I started designing my own wood plates, and they would just pivot. There's the pivot point at the back, and I would use simple brackets and simple fasteners to push and pull the top plate. Does that make sense? The top plate would move in relation to the bottom plate just by turning this screw. And then in my 3D software, I added a elevation screw. So this is the bottom plate of the barn door tracker. That's the existing plate, and that would allow me to change the elevation a slight amount. Again, I just needed about a degree of motion in both of these axes, and a metal plate here to protect the wood. I did a full mock-up with my existing barn door tracker base with the measurements and saw a collision problem. Oops. So I needed to move the bolt out of the way. I don't know why, but I made the bottom plates quite small, so I resized everything, moved things around a little bit. Now I've got the proper clearance for the altitude screw, but I saw I was getting close to the motor. It's a good thing I made the bottom plate bigger, serendipitous, so I was able to move the motor outboard to avoid collisions with that bottom plate. So I started to get the bits. I needed more hinges, obviously, to do this, and some nuts and bolts and things like that, some L brackets to make all this work. And I sat down a couple of times to sort of assemble things and put it together. I also wanted to reduce the friction between the two pieces of wood, so I thought about that for a while to get some materials. All the while, I started to sort of put this on the back burner. I was getting a bit distracted. I wanted to focus on some other things. So it took a while to actually come up with a solution here. I was stumped for a while. Yeah, it's made of wood. When I cut the tiles and then dry fit everything together, I found a new interference problem, that the pivot point was right where the existing hinges would need to go for the bottom of the barn door tracker. So I didn't know what to do. I continued, though, to use the barn door tracker. It was still functional, no problem with it. 2017, up in cottage country, I used the slow motion control under it and was able to very easily get to a good polar alignment. And that's the Pleiades, and you can see a little bit of the nebulosity in that. Again, in not a terribly long exposure, 45 seconds for that. So So then, February 18, 2018, I sit down, okay, today I'm going to do it. I'm going to finish this thing, hell or high water. And was looking at the parts and trying to figure out how to solve it, and then light bulb. I realized if I take my whole Altaz base and flipped it upside down, all the interference problems went away, which if you look carefully at ZZJ's design, he's doing that. So when I turned the Altaz base upside down, it all worked. So I was energized, I put it all together, so here's the front of it. There's the Altaz plates, and there's the pivot point, big bolt through there, and there's the altitude screw. So a simple eye bolt, and that pushes against the bottom plate to increase the elevation. I'd moved the finder back to the top for some reason again. Here's the back of it. There's the azimuth screw. That's not the final configuration, but you can see it pushes or pulls on those two angle brackets there. So it all worked. And I've added vinyl tile between to reduce friction between them. So very happy with that. So I took it outside into the backyard, did a test, and I went big, 300 seconds, and that was without a proper polar alignment. Just super, super quick polar alignment, 300 seconds, nearly perfectly round stars in a fast part of the sky. I was near the ecliptic there. So, was it worth it? Yeah, kinda. You could see you could build one of these for less than $100. If you already have a ball head, you're good to go. If you've got a lot of these parts in some bins or boxes in the basement, you can do this pretty easily. The Altaz base on the bottom, you don't have to add that. You can build from Gary Cernick's design. He says you could do it for 20 or 40 bucks, but I think you're probably into 100 when you add some of the other bits to it. The time, if you look at the times, these are all kind of screwy here. The barn door tracker proper, working at a casual pace, sort of on weekends and rainy days, I was done in 6 months. But the Altaz base, when you look at that, 2.5 years. So again, I got stymied, but it was a low priority at this stage because the solution was sort of working there. But overall, I enjoyed it. Lots of kudos and thanks. Lots of people helped me out with this. Obviously, I went to lots of hardware stores, lots of electronic stores. Too bad Active Surplus with the Gorilla is not still around. And I used lots of software. I used Visio for planing purposes and electronics. When I build electronic circuits, I use the free software Express SCH and PCB to help do the circuit design. It's very smart, easy to use software. And I use the old discontinued. I still use the Autodesk 123D for my 3D design, and that helped me avoid some collision problems with it. If you're interested in building your own and you want to do it real simple, just go to Gary's website and follow his plans. It all works. If you want to build one like mine, I've documented everything. I've documented all the steps, all the painful mistakes that I made, all the trips to the hardware store over and over again. But I've documented all the parts that you need, all the supplies, and all the tools. And I can give you those lists if you want to do that. There's a wide field photo. I just love doing stuff like that. I did that when I was down in the US for the eclipse. And that's a 3-minute shot with a fisheye lens. So that's the kind of stuff that you can easily do. So I don't know what my time is like, but thank you. And if we have time for questions, I'll take it. Hi, question way at the back there.
Hi, I have a comment and a question. The comment is a replacement. Is this working?
Yeah.
Oh, good. Can't tell. There's A1 Electronics, which is on North Queen by Sherway Gardens.
Yeah, I've gone there. I didn't go there for any of the parts for this project, but I go there for other stuff.
Yeah, I mean, that place is full of junk, more than Active Surplus, and if it ever catches fire, they're going to have to evacuate Etobicoke.
The guy that runs that place, he's a barnacle.
Oh,
he's just a mean person. But if you're on his good side, you ask, where where is this kind of capacitor? It's aisle 3, fourth shelf, in the rusty old box. Okay.
Yeah.
He knows where everything is. Sorry.
Yeah, it's a crazy place anyway. My question is that 4 RPM DC motor, because I'm thinking that's really a slow speed for a DC motor with commutators. I assume it's got some segments, whatever. How picky is it on the motors? And like, I'm surprised that a DC motor will run reliably at 4 RPM, but you can comment to that.
For me, it's working well. That's a good point that it's a DC motor. It's not a stepper motor, but it's functioning fine for me in all these trials. I've not had any stalls. It's not going the wrong direction or things like that. So yeah, it's working well. Again, there's some unknown factors. That motor was provided in the kit, so I don't know exactly where it came from and what the specs of it are. I didn't look up any of that information. That was one of the bits that Ian gave me, so I just went ahead and used it. Yeah.
How long does it take you to get started?
So the startup process to do this is pretty quick, all things considered. It's not nearly as involved as obviously a full equatorial mount setup. So I have it on a fairly flimsy tripod here right now, but I usually take a fairly robust, heavy tripod, set that up, roughly aim it to Polaris. The fine tuning of Polaris with the Altaz base now, I think is pretty straightforward because I've got a little chart with me and I know where Polaris should be and I know how the finder scope is presenting it. So it's probably 15 minutes of setup and then I'm ready. Then it's just what I want to do with my camera exposure and all the usual stuff in that respect. But the setting up the barn door itself, 10, 15 minutes. Yeah. And
how long in a night can you go?
So that's a good question, and that all depends on how long you build that curved arm. So the curved rod that's on the bottom here that you can see sticking out, that defines your total run there. So however long that is. Now there's other factors. The plates will open up so far, but at some point you'll get into a balance issue. So you gotta watch out for that as well. So I suppose you could have a longer arm in it, but you're gonna have to make sure that it's balanced, that it won't flop open at some point. So all these types of devices often have limits like that. The swing arms do. The classic barn door tracker has a limit. I'd have to think about what the total time is for that, but it's maybe a couple of hours. So it's been fine for my purposes so far. I don't know if you've noticed it, but I turned it on, and it's been running the whole time. So it's moved about 5 degrees or so during the whole time. It's opened up as I've done that. So look at the image at the beginning of the video and at the end. And you'll see that it's been moving the whole time. Anything else? Any other questions? I see Clay's got one at the back.
Hey Blake, how do you reset it when you're ready? Say it's reached the end of its travel.
Yeah.
How do you reset it so you can start all over again?
That's super easy to do. You just lift it up. I've disengaged the motor gear and the small gear. Just spin this guy up to the top till it reaches the top, and then just make it mesh in again. So it's easy to pop it back in there. And it's running again. So you just spin the gear all the way back up to one of the limits again. The system that Gary Saranic designed, or at least that I've used, has a north-south switch on it. So if somebody goes to Australia and you've built that into your barn door tracker, you just remember to flick the switch and you're going the other direction for the southern sky. I've taped the speed control because I've been trying to really carefully calibrate it. It's a multi-turn pot. I forget how many turns it does from end to end, but it's super sensitive. So I keep bumping it, knocking off a little bit. So that's why I've got it taped down here. Not that it's falling apart, but I just don't want that knob to move anymore. So I've got it in a nearly perfect sidereal motion. Another thing, another little trick that I've learned in all of this is to I was working backwards. I was doing shorter exposures and then longer exposures and longer exposures, kept doing that and looking for trailing in the increasingly longer exposures. But now my workflow is different, and again, this speeds up the time, the setup time as well, that I start with an extremely long exposure. Say I'll do just a 5-minute shot right at the beginning. And with the intention of maybe doing 2-minute or 3-minute exposures. So I'm kind of using double what my planned exposure is. I let it have that first run, and I look for trailing to see if my polar alignment's good and if I need to adjust the speed control a lot. Then I drop it, my exposure back to half, and I have no trailing then. I have round stars at that stage. So that's just a slightly, it sounds counterintuitive, but I think it's a much better workflow to start with a super long test exposure, then go back to the normal exposures. Yeah. Yeah, a couple of questions in the middle there. There's a mic there if you want, right beside John, you're right.
Not sure about the use of your altitude adjuster. Are you using that mostly to polar aligned, or are you using during the shot because it's not motorized?
No, not during the shot. So during setup, I'll be looking for the North Celestial Pole here in Polaris, and then I'll use this to increase the height or decrease the height. And you'll barely be able to see any motion here, but then I use this screw that's at the back to adjust the azimuth now. So as I turn this, it's moving left and right and up and down.
It's just
so this is strictly
adjusting the tripod.
It's strictly for the setup.
Okay. Thank you.
So when I put it on the tripod, I quickly do a rough alignment to 45 degrees up, right? And I'll look for Polaris in here, and that's close enough. Then I'll do fine tuning with those two screws like I would on an equatorial mount with the polar axis scope to dial into the North Celestial Pole. Yeah, and then I don't touch those anymore after that. I have found a weight balance issue when I truly have this at 45 degrees, and if I've got my camera quite far back, it wants to flop open. So the simple low bandwidth solution that I'm going to do there is I'm going to put a big rubber band right here. But I could have a fixed fastener there, so I'm pushing or pulling on a nut on that. That would fix it as well, but for now I'm just going to put a heavy-duty rubber band on it, and that will take care of that. There was a question here, yeah. Where'd that mic go? Tom's got it.
2 questions. How did you solve, if you can quickly, how did you solve the coaxial, getting the finder scope on the same axis as the hinge?
So I haven't tested this in the field yet, but I'm convinced it will work. What I was thinking is when I had the finder scope up here, that I would open and close it during setup. I would open and close, and I could do this in the daytime, right? Aim to a hydropole a couple of kilometers away. And as I opened and closed, I should see on the crosshairs in the finder that the hydropole stays right where it should be. So then I would know that this is coaxially aligned with this hinge. But the technique, see if I can remember it here, the technique that I read somewhere on the interwebs was to just crudely aim to Polaris, aim the camera towards Polaris, and just do it with the camera. Essentially the same thing with the camera, and dial out any motion that way, and then it's good to go. I'm missing a step or two there, but I found that procedure, and it sounds like it will work perfectly. So I had tried to do it on the top plate here, and I wasn't satisfied with the results. So I've got this new procedure that I'm going to use, and it should work fine.
And one other question. If I want to avoid using, I don't know if you can be able to answer this, but if I want to avoid using the curved rod, Is there a way, have you thought about, is anything waiting?
So there's a lot of interesting designs for barn door trackers, a number of which that don't use curved rods. There's something called the dual arm. So this is a single plate, but a richer design is that there's another plate that's going this way, and the rod pushes the second plate, and that's doing something trigonometrically to compensate for that. So the dual arm design uses straight rods. You've got two things that are pushing up the camera, and that also is quite accurate. Lots of people now are using Arduino and have variable rates on the motor. So straight rod, and you program a variable rate, right? Hire these guys to do it. Would you help us with that? You're all crackerjack with Arduino stuff, so that's another way to do it too, just with code, right? So there's a lot of solutions to avoid the curved rod. The curved rod thing is pretty straightforward, though. You just get an old piece of furniture, not something in the dining room, but a nice round table, and bend the rod around a nice big round table. So there you go.
Okay, ladies and gentlemen, Blake, thank you very much.
Thank you.